Hello everyone. So in the last class we learned outlier. Okay, so here I had written one data set 48, 49, 59, 76 and 98, and here 98 is outlier. Okay, so with this definition we defined the outlier. So an outlier is a data value that is very different from other value in the data set. So here we have one data set. Okay, 48, 49, 59, 76 and 98. 98 is very different from these values. Like these values lies in the in the range of suppose we can say the 48 to 76, but 98 is totally different. Okay, so today's agenda is how to find an outlier mathematically. So in this class we will try to calculate, or we will try to find outliers mathematically. So for the calculation of outlier we will use this method IQR, interquartile range method. So don't worry if the name sounds very difficult. So by the end of this class you will be able to solve any IQR question. Okay, so first let me explain the word interquartile, like IQR. IQR. IQR means interquartile range. Okay, interquartile range. So our first job is to understand what is interquartile. Okay, so if I will ask what is the meaning of inter, so what you will give the answer? Inter means between, and quartile means four equal parts. Okay, so what is the meaning of inter? Inter means between, quartile means four equal part, four equal parts. Okay, and what is the meaning of range? So range means difference. Okay, so interquartile range means difference between the first quartile and the third quartile. So from this what we can conclude, like interquartile range means the difference between the first quartile means Q1, and the third quartile means Q3. Okay, so what is this IQR? IQR is nothing. It is the difference between the first quartile and third quartile. So we can write IQR equal to Q3. Q3 is the third quartile, and Q1. Q1 is the first quartile. Quartile means four equal parts. Okay, so now the question is, what is Q1 and Q3? Okay, and how we will calculate Q1 and Q3? So suppose we have one data set. Okay, and in this data set we have some data point 10, 12. This is data set. Okay, and in this data set we have some data point 10, 12, 14, 15, 16, 20, 22, or any other random value, suppose 98. Okay, so before calculation of Q3 and Q1, you have to always ask one question to yourself: is my data already arranged? If your data is arranged, then no problem. If your data is not arranged in the ascending order, then your first job is to arrange your data in the ascending order. Suppose if you have one data set like this. Okay, so 10, 12, 20, then 15, 14, 16, 22 and 98. Then this given data set is not arranged in the ascending order. So first what you will do the arrangement of this data. So you will arrange this data in the ascending order. Ascending order means Bhartekram, means 10, 12, 14, 15, 16, 20, 22, 98. Once you will arrange your data, arranging your data in the ascending order means you are doing nothing, but just you are sorting your data. Okay, so what you did, you sorted your data. So first you will do the sorting. Okay, it's a compulsory thing before applying any IQR method. Then in the second step, we will count our observation, means we will count our data point. So here 1, 2, 3, 4, 5, 6, 7, 8. Just wait. Yes, recording is on. Okay, so here we have 8 data point. Okay, so 8 data points means observation. Observation means total number of data points. So here we have total 1, 2, 3, 4, 5, 6, 7, 8. 8 observation. Then after we will calculate Q1. So now our job is to calculate Q1. Q1 means quartile 1. Okay, Quartile, quartile 1. So for the calculation of quartile 1, we will write a very simple formula. Q1 equal to 1 into total number of observation plus 1 divided by 4. Okay, so here we have total, suppose I am adding one more data point here, so 100. Okay, so total we have 9 observations. So I'm writing here, I'm just changing this. So here total we have 9 observations. So in this formula we will write 1 into 9 plus 1 divided by 4. That means fifth position value. So fifth position value is 1, 2, 3, 4, 5. That means 16. 16 is our quartile 1. 16 is our quartile 1. So we calculated successfully our quartile 1. Okay. Similarly, we will calculate our Q3. Q3 means quartile 3. So for the calculation of quartile 3, we will write 3 into total number of observation plus 1 divided by 4. Why we are writing here 4? Because we are calculating the quartile. Quartile means 4 equal parts. Okay. Here I had already written quartile means 4 equal parts of any data set. So that's why we are dividing with 4. So here 3 into total we have 9 observation, 9 plus 1 divided by 4. Okay, I think here I did one mistake, right? 9 plus 1, that is 10. 10, that means okay, sorry, extremely sorry. So here I did one mistake. Okay, so 9 plus 1, that is 10. 10 divided by 4, that means 2.5. So now this is becoming little bit complex, but still I will explain these things. So 2.5 position, this means first we will write the second position value. So second position value is 12, then plus 0.5 of third position value. So third position value is 14. So 12 plus 0 point, what it will become, like 70 and 7.0. So 19 is our Q1. Okay, so here Q1 is 19. So Q1 is not 16. So here our Q1 is 19. How we will calculate our Q1? So just we will use this formula, 1 into total number of observation plus 1 divided by 4 position. Okay, so the position value. So here I'm getting the 2.5. 2.5 means 2.5 means so the value will be in the in the range of this. Okay, so for this, what I did here, first okay, let me check the calculation, just wait. 14 into 0.5. Okay, now correct. Okay, so by this we will calculate our Q1. In the same way we will calculate our Q3. So here what will be our Q3? 2.5 into 3, that means 7.5. 7.5 means, so the value will be Q3 will be 7 plus 0.5 of 8th position. Okay, 7th position and 8th position value. At the position value, so at the 7th position we have this is 6 and this is 7. So at the 6th position we have 20 and at the 7th position we have 22. So what we will write here, we will write 20 plus 0.5 into 22. So 20 plus 20 plus 11. So what it will be? It will be 31. Once we will calculate the quartile 1 and quartile 3, then we will calculate our interquartile range. So interquartile range is nothing, it's the difference of quartile 3 and quartile 1. So then we will calculate our IQR. IQR is nothing, Q3 minus Q1. So Q3 is 31 and Q1 is and what's the value of Q1? Q1 is 19. So 19 is our Q1. Just 31 minus 19, so it will be 12. So our interquartile range is 12. Once we will calculate the interquartile range, then we will calculate our upper limit. Upper limit means upper bound, lower limit means lower bound. So for the calculation of upper limit, we have one formula, upper limit or upper bound. So Q3 plus 1.5 times of interquartile range. Okay, why we are taking 1.5, I will explain later. So just focus here. Okay, Q3 is 31 plus 1.5 times of IQR. IQR is 12. So just 31 plus 1.5 times of 12. So it will be 49. So 49 is our upper bound. Upper bound means upper limit. Okay, so this is our upper limit. In the same fashion, we will calculate our lower bound. Okay, so LB, lower bound means lower limit. So lower bound will be Q1 minus 1.5 times of IQR. So Q1 is 19. So we will write here 19 minus 1.5 times of IQR. IQR is 12. So 19 minus 1.5 times of 12. So this will be 1. Okay. So lower bound is or lower limit is our 1. Okay. So Okay, so here I can write one thing like our upper bound is means our upper limit is 49 and our lower limit is 1. Okay, then now we will compare every value with this limit. Okay, so now our job is to compare each value with this boundary. Okay, like we will compare our data point with this. So for the comparison, we will ask some question like is any value which is smaller than 1? So first question what will be, is any value which is smaller than 1? Then here we will check same thing in our data point. So our data point starts from the 10. So what will be our answer? So our answer will be no. Okay, so is there any value which is less than 1? So our answer is no. Then again we will ask one another question, is there any value which is greater than 33? Oh sorry, 33 I'm saying 49. Is there any value which is greater than 49? So we will compare this, we will check in our given data point. So yes, we have two value, okay, which is greater than 49. Okay, we have two different value which are the greater than 49. So our first value is 98. Okay, 98 is a greater than 49, and another value is another data point is 100. 100 is also greater than 49. So what it means? It means 98 and 100 is outlier. 98 and 100 are outliers for this data set. Okay, so this is the way how we will calculate our outliers mathematically. Okay, I'm summarizing all, so just focus here. Okay, here first we have calculated our q1, then q3. Once we will calculate the q1 and q3, then we will calculate our IQR. IQR is nothing, it is the difference of q3 and q1. q3 means quartile 3 and quartile 1. Quartile means quartile is nothing, it's the 4 equal part of any data set. Like suppose if we have one data set, so we can divide this data set into 4 equal parts. So part 1, part 2, part 3 and part 4. Okay, so this will be our q1, q2, q3 and q4. So q1 is the quartile 1, q2 is quartile 2. Quartile 2 means median. Okay, we can say this is our median, quartile 3 and quartile 4. Okay, then we will calculate our interquartile range. Once we will calculate our interquartile range, then we will define our upper bound. Upper bound means upper limit. Okay, upper limit. So how we will define our upper limit? So for the defining of upper limit, we will do one simple calculation. Q3 plus 1.5 times of IQR means interquartile range. So by using this formula, we will get our upper bound. Once we will get our upper bound, in the same fashion, we will calculate our lower bound. So for the lower bound, we will write one formula, quartile 1 minus 1.5 times of IQR. Using this formula, we will calculate our lower bound. Lower bound means lower limit. Then we will check whether the given data set lies between this upper bound and lower bound or not. If our data set will be in the range of upper bound and lower bound means LB. Okay, if our all data points lies between this only, then we will say this data set have no outliers, like zero outliers. If any value will be beyond this upper bound or this lower bound, so that data point will be our outlier. Suppose for this example, we have two data points 98 and 100, which is greater than 49, means this is greater than our upper bound, greater than our upper limit. Okay, so this is the method. By using this method we can calculate our outliers. Okay, so might be you may ask one question, sir, why we are taking 1.5? Okay, why do we use 1.5? Like here, why we are taking 1.5, or why we are using 1.5 times of IQR? So the answer is the value 1.5 is a standard rule in the stat. Okay, so what it will do? It creates a reasonable boundary around the normal data. So once we will we will multiply with 1.5, then it will create one reasonable boundary uh, within the given data point. Okay, and the value outside this boundary are considered unusually far from the rest, and they are treated as outlier. They are treated as possible outliers. So this is very simple method, IQR interquartile range. Okay, these are the calculation, and in the next lecture we will learn the calculation of Z score. Okay, in the next lecture I will teach you how we will calculate our Z score, and how we will detect or how we will find our outliers by using Z score method. Okay, so bye bye, take care.